Welcome to Next Round Coding. Today we're going to solve Jump Game 3. So the problem states that given an array of non-negative integers ARR, you are initially positioned at start index of the array. When you are at index I, you can jump to I plus error of I or I minus error of I. Check if you can reach any index with value 0. Notice that you cannot jump outside of the array at any time. So first of all, let's understand the problem. So here is the example 1 and our start index is given as 5. So we are currently standing at index 5. Okay. Now from index 5 the value is 1. So we can do from index 5 we can go one step before. So we can do this step I minus error of I. So from index 5 we can go to index 4, right? Now again from index 4 the value is 3. We can again go to 4 minus 3 means index 1. We come up to index 1. Now from index 1 we can do go to this. So I plus error of I means 1 to index 3. When we reach the index 3 the value here is 0. And our problem state that we need to, if we able to reach any index which have value 0, then we need to return true. So for this case we can easily go from the start index 5 to a index which have value is 0. That's why the result of this test case will be true. Now this one is example 2. Our start index is index 0. So here first of all in the index 0 and the value here is 4. So we can go from 0 to plus 4 or minus 4. But if we do minus 4, we can go out of bound. So we will do plus 4. So if you do plus 4, it would be index 4, right? Now from index 4, we can go minus 3 or plus 3. So 4 minus 3 would be 1. And if we do 4 plus 3, it will go to out of bound. So we can go from 4 to 2, sorry, index 1. And from index 1, where the value is 2, we can go to 1, 2, 3, which have value equal to 0. That's again from starting index 0, we can reach a index which have value equal to 0. So the result of this test case will be true. Now here is the example 3. Our starting index is index 2. So we are currently at index 2 and here the value is 2. So we can do I plus 2 or I minus 2. If we do I plus 2, we can go to index 4. If we do I minus 2, then we can go to index 0. Now in the index 0, we have value 3. If we do 0 plus 3, we can go up to 3. And if we do 0 minus 3, it will go out of bound. And same for index 4. From index 4, if we do 4 plus 2, it will go out of bound. And if we do 4 minus 2, it will again come to index 2. So from index 3, again, if we do plus 1, it will go to 4. And if we do minus 1, it will go to index 2. So you can see that there is no possibility to reach the index 1 which have value 0. That's why the answer would be false here. Now let's see the approach. So for this case, we are starting at index 0 and we will do here a simple DFS. To do a DFS, we need a visited array. We have taken a visited array of same size and initialize it with all zeros. So now start our DFS with the first starting index means 0. Now from DFS of 0, we have two options. One is minus operation, one is plus operation. In zero index, we have element 4. So if we go with minus operation, it will be 0 minus 4 would be DFS of minus 4. And for plus operation, it would be DFS of 0 plus 4 would be 4. And when we are calling DFS of 0, we need to make DFS visited array of 0 as 1. Now we will call DFS of minus 4. When we call DFS of minus 4, it will goes out of bound. So it will directly return false. Now come to DFS of 4. When we are calling DFS of 4, first of all make the array the visited array for to 1. Now we have two choices, minus and plus. If we do minus, so 4 minus 3, it would be DFS of 1. Another is DFS of 4 plus 3 means 7. Now from DFS of 1, we have two choices. First of all, we need to make visited array of 1 to 1. And then if we go with minus, at index 1 we have 2. So 1 minus 2, it would be minus 1. And if we go with plus, then it would be DFS of 3. Now DFS of minus in 1 is out of bound, so it will return false. Now DFS of 3, when we check DFS of 3 is 0, that means we reached a index where the value is 0. So it will be returned true and update the visited array over here. Then for DFS of 1, one get false, one get true. So if any one of them is true, it will return true. And for 7, it is out of bound, so it will be returning false. Now for DFS of 4, one is true, one is false, so it will return true. And for DFS of 0, one is false, one is true, so it will be returned true because one is true. So the answer for it will be true. Now let's see the pseudocode. So first of all, there will be a Boolean function of DFS which will take a index, the nums array, and the visited array. Now check if I is lesser than 0 or I is greater than equal to n or not, or if you already visited this index or not. If any one of them is true, we will return false. Now check if our current index value is 0 or not. If it is equal to 0, you can directly return here true. Now just update the visited array. Now just call two recursive call here. So first of all, DFS of I plus nums of I, comma nums, comma visited array, or DFS of I minus nums of I, comma nums, comma visited array, and that's all. Now let's move on to the editor and code it up. Now I am in the editor. Let's code it up. So we need a Boolean function named DFS. We have a current index I and a vector of int and arr, and we have a visited array. We need to know the size of the array. Now if we going to out of bound, return false, and if we reach a index where the value is 0, we need to return true, and we need to update the visited array, and at the end we just return two DFS false. Error of I, my error, one of the errors. Now let's create the visited array. Let's initialize the n, and let's call the function. Great. Now let's run it. Yeah, it is running fine. Let's submit it. Yeah, I got a right answer. So the time complexity of this approach would be big O of maybe, and the space complexity of this approach would be big O of n as well, as we are using a visited array. Thank you.